What's going on, everyone? Welcome back. Patrick here. Moving on to the next example, we have to provide a sample space for each of these scenarios here. So scenario A, 2 students out of a class of 4 will be asked to write a test, and then part B, you try on 3 different pairs of shoes and categorize them as too small, too big, or fit well. So let's start off with part A, and let's label these 4 students as A, B, C, and D. And so notice that 2 of these 4 students will be asked to write a test. So what are the different ways that could happen? What would be the sample space of this? Well, notice that A and B, student A and B, can go together. And notice that the order doesn't matter in this case because they're just both going to be writing the test. So AB, BA are considered the same combination. So we got AB, also student A and C, A and D, and then what else? We can have B and C, we could have B and D, or we could have students C and D. And that's basically all of the combinations right there. And notice how there are 1, 2, 3, 4, 5, 6 combinations, and that makes sense if we go back to counting principles. Taking 2 students out of a class of 4 to write a test, the order doesn't matter, so the number of ways that could happen would be 4 choose 2. And 4 choose 2, what's the formula for that? 4 factorial over 2 factorial over 4 minus 2 factorial, which is just 2 factorial. And so that would be what? 24 over 2 times 2, which is 4, which indeed would give us 6 different ways that could happen. Right? So if we label the students A, B, C, or D, these are the different combinations of where 2 students can be chosen from a class of 4 to write a test. Now in part B, this one's going to be a little bit more complex, I feel, because here the order does matter because you're trying on 3 different pairs of shoes and you have to categorize them as too small, too big, or fit well. So what would happen here is that the first shoe, we can represent this in a tree diagram. So the first shoe can be either too small, too big, or fit well. And then the second shoe would be the same thing, too small, too big, or fit well. So if the first shoe is too small, well, the second shoe can be too small. It could be too big, or it could fit well. And then this one as well. If the first shoe is too big, well, the second shoe can be too small, too big, or fit well. Same thing here. If the first shoe it fits well, then the second shoe can be too small, too big, or fit well. And then the third shoe, and then each of these would have 3 different branches. Right? So notice in this case, what's happening is that there's 3 possibilities for each shoe, and then there's 3 shoes that we are trying on. And so the total would be 27. If you continued this tree, the total number of branches at the end would be 27. Now, how do we represent this with a sample space? Because that's what we're doing here, right? We've already gone through how to count this. How do we represent it with a sample space? Well, what you would do is this first branch, if we went to the third shoe, the uppermost branch, the first shoe would be too small, the second shoe would be too small, and the third shoe would be too small. And so one of the ways, or one of the elements in this sample space, would be 3 too smalls. Now, what would be the next branch? Well, the next branch would be this B here, but the first shoe and the second shoe would still be too small, but the third shoe would be too big. So then the next branch would be S, S, and B. And then the next branch would be the third shoe fits well. So the first shoe would be too small, the second shoe would be too small, and then the third shoe would fit well. And then we move down, so the first shoe would be too small, the second shoe would be too big, but then the third shoe would be too small, right? So it would be SBS, right? And if you continued this pattern, there would be 27 of these, and then the last one would be fits well, and then that third shoe, that last branch, would be fit well as well, right? You'd have S, B, and F, but then that last branch would be F, F, and F. So that's where it would end. Like that. All right, and everything would in between would be those branches in between. Again, the total number of elements in this sample space here would be that 27.